we are just going to be given the tip of the day. So what is going to happen once we actually just have everything that we are using in the hub network to make sure that everything is secure? What is going to be securing the parameters or the solutions that we have in our hub or central point of connectivity to on-premises? So this is the Zero Trust principles, 5 steps, and then how we're going to actually just get it.
Welcome to the Tekitok Podcast, where we embark on a journey through the ever-evolving realm of SAP and IT operations, automation, artificial intelligence, and cloud technologies. Whether you're an IT professional, a business leader, or simply curious about emerging technologies and industry insights, our episodes will be your compass in navigating this dynamic landscape with real-world experiences. Join us as we demystify complex concepts, explore innovative trends, and engage in stimulating dialogue with industry experts to empower you with insights that matter. The views expressed by our hosts and guests are their own and do not reflect the opinions of their respective companies. The producer of this Tekitok podcast assumes no responsibility for any public content, ideas, or recommendations shared.
All right. Well, welcome back today. We have Evren again from Microsoft following up on the security. And today we're going to be talking kind of an overview of 3 different episodes we're going to cover coming up. First of all, welcome back, Evren. Thank you very much.
Thank you so much, Linh, for hosting me.
And Tekitok Podcast, I know the security is a big question right now as part of, overall security stance with customers, especially moving to the cloud already there and moving to the next layer of zero trust. So this is a big topic. So we want to break it down for you. Zero trust and security, kind of a 3 principle, right? Around verify explicitly and using least privilege access. And assume that it's going to be a breach. So there's 3 different areas there. We're going to dig deeper into each of these topics and, go into the subset of what zero trust security is about. First, we're going to tackle today as well in the deeper dive with the network encryption. Obviously, that's kind of the first level of production we need to do. And then in the next few episodes, we're going to discuss other things around storage, level encryption, and then the threat detection. So all of this in the context of enterprise computing in the cloud. You've got tools like Sentinel, which obviously for SAP customers as well will basically be a security event information kind of management platform scene. But let's talk about the basic principles of most of these so that everyone can give us why they're important, give us some evidence around, what customers are doing, what questions they're asking, and what Microsoft is doing to help them protect the assets in the cloud, as we say. So, Evren, over to you. I wanted to make that brief intro for the Tekitok podcast people. Our audience today actually have had an episode before from you in terms of just overall Microsoft security. So I'm really happy to have you back to dig deeper into this, zero trust kind of security concepts.
I am so glad to be here, Linh. I think that has been a while since last time you and I have actually spoken, and I covered the zero trust security and cloud DMZ topic. So right now, as we promised in the first episode, that we were just going to go deeper into the zero trust security, what exactly it is from the real work perspective. So what exactly did we do? So quick intro. My name is Evren Buryuk. I'm a principal cloud solution architect from Microsoft International Customer Success Unit. I also lead worldwide SAP on Azure connected communities from the technical perspective. I'm also part of the Azure one-stop team. And also, we are looking at internal cloud solution architect scenarios and solutions that are actually just coming from their end customers. So security is my passion. I am certified across all security parameters and all security solutions across Microsoft and also third-party providers. So it has been actually quite a journey for me. So, and then today, again, like when I spoke about the zero trust security in the first round, we didn't necessarily get into the key details, but we were just given the overall like high overview on the solution, solution details. So when we are looking at like zero trust security, there are three actually main principles. These are verify explicitly, use least privilege access, and assuming breach, as you mentioned, Lynn, in the first intro. So verify explicitly means that what we tell our customers that they should be always authenticate and authorize based on all available data points by way of using conditional access policies for customers' Azure VPN gateway connections, and even secure shell, which we also call it SSH, and remote desktop, RDP for the user to virtual machine connections. So again, this is like a very, simple explanation, but it's not necessarily just like, showing all the key details, but I'm just going to be showing. Cool. So use least privilege access is basically limiting the user access with just in time and just enough access, JEA. Most of the time, people do not understand the difference between just in time and just enough access. I mean, just enough means you're given the privilege to the person to do certain work, and then after that you actually disable that privilege, and then that person is no longer actually just taking care of that solution. Basically, we are using risk-based adaptive policies and data protection by way of configuring the Microsoft Enterprise Edge devices to use static connectivity association key, which we also call it CAK. I'm going to be speaking more on that.
Okay.
So this is for the Azure ExpressRoute with direct ports, and also like using managed identity to authenticate ExpressRoute circuit resources that we do this. So when we look at the assuming breach, this is actually, open-ended, statement actually, assuming breach. So what exactly it means? So what we say to our customers is that they should minimize blast radius and segment access, and then they should be verifying end-to-end encryption and use like analytics to get visibility, and then they can actually drive threat detection by capturing that visibility by way of protecting network traffic with encryption methods and protocols that will provide them the confidentiality, integrity, and authenticity of the data in transit, which is everything the customers are actually just looking for today. So we will be using technologies like Azure Monitor to provide ExpressRoute network, like, performance metric and alerts. And we're going to be using Azure Bastion to manage, individual sessions from the Bastion service and delete or force a disconnect after the connection has been established. This is actually pertaining to the just enough access as well, because you establish the connection and then you disable the connection or you disconnect the connection. So basically, we are always just going to assume breach. That's why we're going to be using this level of encryption for network traffic by leveraging the network layer encryption to secure and verify this communication from the internet or the customer's on-premises network to Azure VNets and even just like virtual machines. So we will be securing and verifying the communication within and across Azure VNets, which is one of the cores, and also the application layer encryption, which is to protect for Azure web applications, and then also like protection for workloads running on Azure virtual machines like the SAP, SAP technologies. So these three principles are just going to be the core principles of Azure Zero Trust Security. And then when we are actually just looking at the, approach, and then how we are actually just going to be, adopting all these parameters, we're going to be looking at this reference diagram. So this reference architecture for this zero trust, security is for encrypted communication between users and admins on premises, on the internet, and also the components in the Azure environment. Basically, when you're looking at the steps, we will be getting any customer to that state where they will have secure connectivity to Azure and Azure services using Microsoft best practices. So this is a reference architecture again, and then any customer that is leveraging cloud technologies, specifically Azure, these are the key steps to actually just achieve that, zero trust security model within Azure. So of course that we're going to be breaking down. So breaking down of Azure Zero Trust Security Principles 1 to step 5. So like implementing network layer encryption by way of, verifying explicitly using least privilege access and assuming breach all the time. And then the second step is going to be securing and verification of communication from on-premises network to like Azure VNet by verifying explicitly and assuming breach, and secure and verify communication within and across Azure VNets, implementing application layer encryption, and again, use Azure Bastion to protect Azure virtual machines. So this is the Zero Trust principles, 5 steps, and then how we're going to actually just get it. Basically, this is the breakdown of the diagram into simple 5 steps to achieve that Zero Trust security can be applied across the reference architecture, which I mentioned in the previous slide. And this can be actually just applied from users to admins on the internet, or even customers on premises network to and within the Azure cloud. And then how we're going to get there, right? This is something that we're going to be looking at. So the phase 1 is as I mentioned, that 5 phases. This is number 1. The network layer encryption is critical when applying Zero Trust, principles to the customer's on-premises and Azure environment. So when network traffic goes over the internet, what we are telling customers, Lynn, this is very important. It doesn't really matter what technologies they use. They should always assume that there is a possibility of traffic interception by malicious attackers. Right. And then their data might get exposed or even altered before it reaches its destination, which is Azure. So what we say, Azure is secure. But what we are also telling the customers that Azure is secure and your data is your biggest asset. You have to just protect it, because this, service providers control how data gets routed through the internet. So basically, we trust the service providers. Customers are trusting service providers, but we also want to make sure that the privacy and integrity of the customer's data is maintained from the moment it actually leaves the customer's premises network all the way to Microsoft Cloud, the hidden the hub network. For example, hub is the central point of connectivity to customers' network, or customers' networks point of entry to Azure before it actually is routed to the spokes. So this diagram, on right of the screen shows that the reference architecture for implementing network layer encryption. So IPSec, for example, is what we're looking at here, is the group of protocols that provides security for internet protocol, which is IP communications, and is the core thing that a lot of customers are using. Hey, my IP address, public IP address, IP groups, IP space, IP address space. What exactly is that is already known by lots of customers. It is the internet protocol. So what the security on top IPsec is doing, IP security is doing for IP protocol, is that it authenticates and encrypts the network packets using a set of encryption algorithms. So that's why IPsec is considered to be the security encapsulating protocol used to establish this virtual private networks, which is the VPNs. And IPsec VPN tunnel is then coming to the picture, and then they say, okay, what is the VPN tunnel then? So what exactly it consists of, right? So it consists of 2 phases. Phase 1, known as the main mode, and phase 2, known as the quick mode. And then what exactly phase 1 and phase 2? Phase 1 of IPsec is the tunnel establishment, because it's all about the tunnel to come to Azure cloud, right? So where peers negotiate parameters for the internet key exchange, which is something that lots of people see, IKE. What exactly it is, right? They say IKE all the time. It is actually Internet Key Exchange, security association, such as like encryption authentication, hashing, like Diffie-Hellman algorithms. So basically, to verify the customer's identity, what happens with IPsec mode 1 and mode 2, peers exchange a pre-shared key, and then this phase 1 of IPsec is then operating in 2 modes on top. So this is going to be the main mode and aggressive mode. So Azure VPN Gateway supports 2 versions of Internet Key Exchange, which is IKE version 1 and IKE version 2, and only operates in main mode. because the main mode ensures that like encryption of the identity of the connection between, the Azure VPN gateway and also the, on-premises device is established. So the question is, I'm sure that audience listening to this is asking, what is the phase 2 then, right? Phase 2 of IPSec, this is actually peers this time negotiate the security parameters for data transmission so that if the data is actually secure from the parameters perspective. So what happens in this phase, both peers agree on the encryption, negotiation and agreement, right? Mm-hmm. They negotiate, so they agree on the encryption and also the authentication algorithm. So basically, this also is including the lifetime value of the security association, which audience actually just hears it or sees it every time it is SA. So it is actually the value of the security association, we just call it, and also the traffic selectors, which is TS. So TS, that is defining what the traffic, if the traffic is encrypted or the IPsec tunnel or not. So this tunnel is created in phase 1, serves as a secure channel for this negotiation. So then IPsec secure IP packets by using either authentication header protocol or encapsulating it, or encapsulating the security payload, which we just call it ESP protocol. Yep. Mm-hmm. So what we say with the AH, it is actually providing the integrity and authentication while this, the payload one, encapsulating security payload, also provides confidentiality, which is the encryption itself. So this phase 2 can operate in either transport mode or tunnel mode. So now, you're going to maybe asking me, what is transport mode? Like customers ask, what is a transport mode? Because these are deep dive under the hood details.
Right.
The transport mode is only the payload of the IP packets get encrypted while in the tunnel mode, the second one, the entire IP packet is encrypted and a new IP header is added each time. Mm-hmm. So IPsec phase 2 can be established on top of this, IKE, Internet Key Exchange version 1 or version 2. Mm-hmm. Mm-hmm. So from the current, deployment perspective, Azure VPN Gateway IPsec implementation supports only ESP in tunnel mode, which means that it is actually encrypting everything. So basically, some of the Azure services use this, IPsec and just leveraging it. For example, like Azure VPN Gateway, which is site-to-site VPN connections, or VNet to VNet connections, or point-to-site connections, as you see in this, diagram. Right. Mm-hmm. So also Virtual One is using it. It is actually VPN sites, user VPN configurations that we will say. So there are no settings the customer actually need to modify to enable IPsec for those services. Basically, I'm speaking about this transport mode, tunnel mode, and everything phase 1, phase 2, and then encrypting the packet, encrypting the whole thing. But what the customer is doing is when they actually just turn on their storage account and they are on Azure, they actually just automatically enable IPsec because they're enabled by default and customer does not have to do anything. So this is the phase 1. Mm-hmm. This is phase 1, how the customer is getting onto Azure and how their traffic is encrypted to avoid any kind of malicious attackers, coming to Azure. Okay. The second one is actually, this is the subset of phase 1, basically the MACsec. I spoke about IPsec in the first round. So MACsec is something that is customers really need to look, because this is a network security standard that applies that, assume breach zero trust principle at the data link layer by providing the authentication and encryption over an Ethernet link. So what is MACsec? It is the media access control security. Is assuming that any network traffic, even in the same local area network, can be compromised or it can be intercepted by malicious attackers. So why we use MACsec is because that is actually something for our customers to just, they can actually just be, they can be, assured that this verifies and protects each frame using a key security. This is the security key, which is shared between two network interfaces, physical network interfaces. So this configuration can only be accomplished between, again, two MACsec capable physical devices. So MACsec is configured with connectivity associations, which are a set of attributes that network interfaces use to create inbound and outbound security. And then these are all the channels. So once you create the traffic over these channels, the traffic gets exchanged over two MACsec secured links. Again, these are all physical points. So then it is having two connectivity association modes after that. So which is something that I actually just mentioned when I first started. The CAK, which is the connectivity association key. So what exactly it is? MACsec secured links, when we actually just they're established using a pre-shared key that includes a connectivity, association key name, which is the CKN. Again, like what did I mention about CAK? This is a static connectivity association key. So we are actually just using it to establish this pre-shared key that is going to include this connectivity association key name, which is the CKN. So I'm actually just speaking a little bit more, telling about what these abbreviations are, because most of the time customers say, hey, is this something so generic, it is inherent in the security? These are just abbreviations that we need to use, right? Because when a customer reads URLs, if they're gonna see this key name, association key name, CKN versus the whole word just written, it is just going to be not necessarily making a lot of sense. So what we do in parentheses, sometimes we actually mention, but sometimes we do not, because we assume that customers know about this, but I am actually just making it more simplified. So these keys, when we actually just established MACsec, these are configured on both ends of the link. So there are two modes. One of them is the dynamic CAK mode, which is the security keys are generated dynamically using the 801 1x authentication process, which can use a centralized authentication to it is actually a central authentication device, such as remote authentication dial, and then in-user service. I'm just saying the whole thing. It is the radius. I didn't want to say radius. It is the remote authentication dial and user service or server. So basically, we also have the Microsoft Enterprise Edge, which is MSEE devices. These are supporting static CAK and storing the CAK and CKN in Azure Key Vault when you configure Azure ExpressRoute with direct ports. So what happens is when a customer needs to access the values in the Azure Key Vault, they need to be configuring the managed identity to authenticate and authenticate the ExpressRoute circuit resources. So this is how they actually just access. So the key value of this approach is to follow the use least privilege access zero trust principle, because only authorized devices can access the keys. And then unauthorized people cannot use the keys, right? This is not like a rocket science.
Right.
There we go. This is just a good example. So what we tell the customers that there are lots of use cases for this, but if they want to use or configure MACsec, on ExpressRoute direct ports, we have written a fantastic article with use cases. Customers can go ahead and just type configure MACsec on ExpressRoute direct ports on Azure. There you go. The link is going to be direct.
Okay. So now we got the VPN covered. We got the kind of MACsec for end-to-end device kind of encryption at the physical level, right?
Yeah, exactly. So so this is just going to give some more information on the phase 2 of the reference architecture. So what we say that as cloud migration becomes more prevalent across businesses of different scales, and hybrid connectivity really plays a key role. So we let the customers know that it's very important not only secure and protect, but also to verify and monitor the network communication between their on-premises network and Azure. So this diagram really simplifies that reference architecture for securing and verifying communication from an on-premises network to Azure. Basically, Azure provides two options to connect to customers, premises networks in Azure. So basically, one of them is Azure VPN Gateway. This is to allow the customer to create a site-to-site VPN tunnel, again, like I mentioned, using IPSec to encrypt and authenticate network communication between customers' network in central or remote offices. So it is allowing individual clients to establish point-to-site connection, which is to access resources in Azure VNets without the VPN device. For zero trust, adherence or zero trust like reference, we are asking the customers to configure the Entra ID authentication and also conditional access policies for their Azure VPN gateway connections to verify the identity and compliance of the connection devices. So, and for that one, if any customer actually just wants to find out more, like I mentioned about ExpressRoute, they can go and just use the URLs and then type, Microsoft Tunnel VPN gateway with conditional access policies, Azure ExpressRoute. So that is going to provide them the high overview and then also some key details to actually just put it on their references. So
when I was asking a question about the context of let's say a new customer project for migration. This is not exclusively one or the other. You could have an ExpressRoute from headquarters to Azure, you might have the other VPN for various different. So customer might have multiple locations. They might have different need for VPN. And also for, I guess in my experience, if you're doing a cloud, like an SAP RISE migration, right? So you may be doing a POC where perhaps you don't have the ExpressRoute because I don't know what the timeline in setting up an ExpressRoute is, but let's say it's a month and you want to get up running quickly for a POC, maybe a VPN gateway connection would be surfaced for the kind of a POC while you're setting up that. So I don't know what the time frame you're looking at most customers encounter when they're setting up these from the ground up.
Yeah. I mean, there is something that to establish the, ExpressRoute circuits you're mentioning, right? I will say like a couple of months. So basically we have our partners that we're working with. And then if the customer actually reaches out to their Microsoft representative so that we can actually just enable that communication with the partner team. Right. So, when we're actually just looking at overall, ExpressRoute is, you mentioned that it is really just providing the, high bandwidth private connection that is going to let customer extend their on-premises network into Azure with the assistance of connectivity provider. So that provider is going to be like, I don't want to name those providers right now, but they're just widely known. A whole list of them. So what happens is when we are talking about the ExpressRoute, now the network traffic doesn't travel over the public internet. Data isn't encrypted by default, right? Because it's not. So to encrypt the traffic or ExpressRoute, we're asking customers to configure an IPSec tunnel. However, keep in mind that when running IPSec tunnels over ExpressRoute, the bandwidth is limited to the tunnel bandwidth, and then the customer might need to run multiple tunnels to match the ExpressRoute circuit bandwidth. So basically, we have some great information on this, like site-to-site VPN connections over ExpressRoute private peering. So if a customer is using ExpressRoute direct ports, they can increase their, network security by enabling authentication when establishing BGP peers of configure MACsec to secure the layer 2 communication. So MACsec then provides this encryption for Ethernet frames, which is going to ensure the data confidentiality, integrity, and also the authenticity between the edge router and Microsoft's, edge router. So when we have ExpressRoute, it is also going to support Azure Monitor for network performance metrics and alerts. So customer can actually just, they can have, better way to monitor. They can protect their data from unauthorized interception but it is also going to introduce an extra layer of processing for encrypting and decrypting network traffic that can affect performance. So because the network traffic going over the internet can also be unpredictable because it must travel through multiple networks, devices. So it is something that customers usually just come to us and say, hey, our connections are so slow, because we say that when you're using VPN or IPSec or ExpressRoute, for example, that you also have to just factor in the public network, condition at that time. So what we tell customers, if they need to avoid performance issues, Microsoft recommends using ExpressRoute direct connection because it is offering reliable network performance and bandwidth, allocation that can customize for the workloads. So when deciding between Azure VPN gateway or ExpressRoute, we are telling the customers to consider like questions. We will say what kinds of files and applications are they're trying to access between their on-premises network and Azure. We ask questions like, hey, do you require consistent bandwidth and transferring large volumes of data? So these are all the questions that you might ask to understand if they need ExpressRoute or not. So like basic questions, you do not need to necessarily just ask them or send them a bunch of scripts to run their testing in the first place. We can just ask certain questions like, do you need consistent and low latency for their applications to perform optimally? Or do you need to monitor the network performance and health of your hybrid connectivity? These are all the things that we might ask because I actually just put the information here that like the key differences between Azure VPN Gateway and Azure ExpressRoute. And as you can see that like you're going to see more and more, features with Azure ExpressRoute versus Azure VPN Gateway. But you mentioned something which actually I think is a key, Lynn. I mean, that's very smart actually. You said customers are using VPN and then, they can actually use point to site using VPN. But also, one thing that you actually just made me think, what about customers who are connecting Azure using VPN, but we get them or we hop them on ExpressRoute circuit? This is something that I think is gonna be very important. I'm actually just going to be speaking about that in the next couple of slides. So Azure VPN perspective, site-to-site and point-to-site VPNs are available. So partners with connectivity automation to virtual WAN Azure gateways, they can actually just use this connectivity. And then we're also we are making sure that partners with signed agreements to deliver connectivity automation to virtual WAN with a mutual agreed upon timeline. These are all going to be available going forward. So these are the key value proposition of site to site and point to site. I actually just make sure that what the customer is getting with the site to site and internet key exchange version 1 and version 2, they're actually just enabled on VPN gateway from 1 to 5, and then they actually they have the IKE version 1 site to site tunnels, IKE version 1 and IKE version 2 on the same VPN gateway. These are the features. So from the point site perspective, this is Open VPN protocol. It is native Active Directory authentication with multi-factor authentication, client-side diagnostics and logs and metrics. These are all enabled. But let's come to the VPN gateway AHA, because this is also the security concern for customers, because if they do not have access to Azure, if they do not have the AHA and then or high availability, I should have actually just written it high availability instead of AHA. So when a customer using Azure VPN gateway, it is consisting of 2 instances in an active standby configuration. For any planned maintenance or unplanned disruption that happens to the active instance, what happens is, and then this is coming a lot, Lynn, I'm gonna be honest. Yeah. When a customer says, hey, I'm gonna use Azure VPN gateway, what about that Azure VPN gateway is not available? So what happens, right? Then we go and just check other people resources. So then there's going to be an answer to that, because the standby instance is going to take over. And this is actually then question is going to be, when you say it is going to take over, do I need to do anything? No, it is going to happen as a service, right? We're using load balancers. It is going to be failing over automatically. And then the connectivity is going to resume the point-to-site VPN or VNet to VNet connections. So the switchover will cause, I'm going to be honest, a very brief interruption. But this is like, hey, did you see that I blinked my eye? You didn't see it, right? You blinked, but I just saw because I was just watching you. So they're not gonna realize. Because what we do is that for plant maintenance, the connectivity should be restored within, I will say, plant maintenance. again, like plant maintenance. We're going to be actually just making sure customers' operations, when exactly it is. Let's say that this is a company in US. They're actually just like, operating from Monday to Friday, business hours from 8 to 5, and then their production, they're doing production every day except for Sunday. And then we are just going to work with the customers to make sure that like their plant maintenance is just going to be fitting into that little time frame. And then that 10 seconds is just not going to be, they're going to be sleeping while we're doing it. So basically it is just going to be, very, very fast. So what about the unplanned issues, right? So the connection recovery is going to be longer at that time. It is like 1 to 3 minutes in the worst case. Have I ever, experienced that? No, I have not experienced that. For point-to-site VPN client connections to the gateway, these are like, disconnected, and then the users need to reconnect from the client machines. Again, this is happening on the unplanned side. So, and then I'm actually just going to go into the, very important topic that you actually just mentioned about. I know that like we have, some time left, like maybe 10 more minutes, and I'm just going to, cover this very important topic, which is the, BGPs. These are the standardized like exterior gateway protocols designed to exchange routing information between different autonomous systems, which is ASEs on the internet. So I don't like abbreviations. That's why I'm just like calling out these names. Right. But this broader gate protocol, the BGP, is used to make routing decisions based on the network policies and reachability information. So in Azure, BGP is used in the context of the virtual network, VNet peering, and ExpressRoute connectivity. This is the underhood information. So this is how the BGP is used in Azure, like, all the steps that you actually just see. ExpressRoute, the first one. When establishing a private connection to the Azure through ExpressRoute, which is, again, leveraging IE standard, which is the, MACsec standard, BGP is used to exchange routing information between on-premises network and Azure virtual networks. So then how is BGP going to help, right? BGP is going to help in dynamically propagating all these routes and enabling the network connectivity over the ExpressRoute circuit. And then number 2, which is actually just going to be the number 2 phase, VNet peering, right? When peering to Azure virtual networks, this BGP can be enabled to propagate the routes between the peered networks. So this is going to allow the seamless communication between resources in different VNets without the need for additional network. And then we have the, step number 3, or the, gateway 3. This is the global reach. BGP is going to be then used in Azure Global Reach, which is then going to, connect multiple VNets across different Azure regions using the Microsoft Global Network backbone. So now the question is, do I need to worry about the encryption in Azure between point A to point B in Azure backbone? I'm asking the question to the audience, do you need additional encryption? Yes or no? Let's say that you're actually just using Azure East US2 region, and then you have deployed availability zones, which are actually just like, subset data centers and fault domains. Right. And then how is the connection going to be happening? It is going to be enabled by Azure MACsec. Basically, the security is going to be from point A for point B. Links are established, physical links, and then the communication is going to be done with the CAKs and CKNs, the things that I actually just mentioned in the first. Right. So right now, let's go into the coexistence, and we're just going to be actually just like, finishing with this important one. This is very important, guys. Whoever is watching it, just hear me out. So before I talk about IPSec or ExpressRoute, I just need to reemphasize that ExpressRoute lets you extend your on-premises network into Microsoft Azure Cloud over a private connection with the help of a connectivity provider. And Linh told me not to say those names, so that's why I'm not saying those names. I'm just joking. So with ExpressRoute, you can establish connections to Microsoft Cloud services such as Microsoft Azure and Microsoft 365. There's no question about that. So basically, this is the connectivity, which is actually just provided dedicatedly only to you. It's not running on the public internet. Right. However, connectivity can be from any to any IP VPN network or a point-to-point Ethernet network or a virtual cross connection through connectivity provider at a co-location facility. And ExpressRoute connections, since they're not going over the public internet, it is again going to allow you to connect privately. Is going to offer more reliability, faster speeds, and then consistent latencies, and then higher security than typical connections over the internet. Right. So now, in the context of ExpressRoute, the Microsoft Edge describes the Edge routers on the Microsoft side of the ExpressRoute circuit. So this is the ExpressRoute circuit point of entry into Microsoft network. So then it is going to be, again, the layer 3 connectivity between the on-premise network and the Microsoft cloud through a connectivity provider. And connectivity can be from any to any IP, VPN network and point-to-point Ethernet connection, or through a virtual cross connection via Ethernet exchange. So connectivity to Microsoft cloud services across all the regions in the geopolitical region, and global connectivity to Microsoft services across all regions, and is going to be within the ExpressRoute premium SKU add-on. And then there's going to be dynamic routing between the network and then Microsoft via the border protocol, right? BGP, and built-in redundancy in every peering location, and connection uptime SLAs. These are all going to be given to you. So now, this is the key. So right after I wrapped it up, I know that I have only 2-3 minutes. What happens when we configure IPSec over ExpressRoute? Guys, I mentioned about all the benefits. Phase 1, Phase 2, Mode 1, Mode 2, aggressive mode, tunnel mode, transport mode. What happens if you actually just put this IPSec over ExpressRoute? What happens? So IPSec, again, is a group of protocols that are going to be used together to set up encrypted connections between devices, right? So it's going to keep the data sent over the public networks, securely. IPSec is going to be used to set up these VPNs. It is going to be encrypting IP packets along with authenticating the source where the packets come from. So now, you can configure the site-to-site VPN to virtual network gateway over an ExpressRoute private peering using an RFC 1918 IP address, guys. Again, let me just repeat that. You can configure site-to-site VPN to a virtual network gateway over that dedicated ExpressRoute connectivity. On that connectivity, establish private peering, and you're using RFC 1918 IP address. So what happens is this configuration provides that it is going to be, the traffic is going to be privately encrypted. Point-to-site users connected to virtual network gateway can use this now ExpressRoute via the site-to-site tunnel. They're leveraging it. They're also it's also possible to deploy site-to-site VPN connections over ExpressRoute, private peering at the same time as site-to-site VPN connections via the internet on the same VPN gateway. Look, you're actually just saving a lot of money as well. So for traffic from on-premises networks to Azure, the Azure prefixes are advertised via the ExpressRoute, private peering BGP, and then the VPN BGP. So the result is actually what you're getting is twofold. You're getting two network routes paths towards the Azure from the on-premises network. So one of them is the network route over the IPsec protected path, and then the other one is that network route directly over ExpressRoute without the IPsec protection. There you go. So this diagram is really showing that within the on-premises network that is connected to the Azure Hub VPN gateway or the ExpressRoute private peering. So the important aspect of this configuration is to provide that routing between the on-premises networks and Azure over both the ExpressRoute and VPN paths. So what happens is, they say that, hey, it is just an overlay over private IP address peering, right? Yes, it is. The main point here is that you have to force the traffic to go through the tunnel and not learn about the same or maybe even shorter routes via ExpressRoute directly. And this is the reason why it can actually just bypass the VPN. So when we have this connectivity over ExpressRoute, you're actually double layering the security or encryption by using IPSec and ExpressRoute direct connectivity. And then, of course, the customers then ask questions like, what about the bandwidth for the SAP workloads, right? Like, how am I just going to be measuring it? So then there is just going to be really dependent on the migration. But we can also tell the customer that we are recommending 10 gig ExpressRoute, connectivity to actually just to establish a healthy connection. So when we say that like side-to-side VPN connections over ExpressRoute private peering, there's also really just a really good, article. We are really just providing the customer with this fantastic tool to make sure that this is actually just provided to the customer using the, overall, MACsec over, IPSec over MACsec, which is then going to be the traffic within Azure is going to have the, double level of encryption. So when the traffic moves between VNets in different regions, Microsoft is then going to be using this MACsec to secure the connection to encrypt and authenticate peering traffic at the data link layer. So then this reference architecture, which I actually just put here, is that going to be providing this security. So one other thing is that encryption alone is not going to be enough to ensure the zero trust security. We should also just monitor the network communication within and across Azure VNets. So, and again, this communication is actually just going to continue, that we are going to be talking about overall application encryption at the application layer by using HTTPS and secure shell and remote desktop protocols and Azure Front Door and Azure Application Gateway. And then we also have the Azure Front Door and Azure Application Gateway with WAF functionality. This is something that we can actually just do the connectivity scrubbing now with Azure Front Door. So this is the DNS-based service optimized content delivery. It is to actually just provide HTTPS with end-to-end TLS. So we have the Azure Application Gateway, which is more on the layer 7. It is going to receive and route incoming HTTP requests to the destination in encrypted form. It's going to decrypt incoming HTTPS requests at the instance level and end-to-end TLS. So, and then of course that we are just going to be given the tip of the day. So what is going to happen once we actually just have everything that we are using in the hub network to make sure that everything is secure? What is going to be securing the parameters or the solutions that we have in our hub or central point of connectivity to on-premises? Yes, we know that MACsec is going to provide IEE standard, IPSec over ExpressRoute provide augmented network layer security, VNet encryption to encrypt and decrypt transmitted. But whatever is going to be protecting inside the hub right here on the left is going to be the DDoS protection. Basically, DDoS is going to be protecting everything. This is distributed denial of service attacks. These are some of the largest availability and security concerns of customers that they are moving their applications to the cloud. So DDoS attack attempts to exhaust an application resources, making the application unavailable to the legitimate users. And then we are just going to be using Azure DDoS to protect everything on top of that. So with this, I'm actually just going to be, speaking very shortly on the virtual machine protection with Azure Bastion, which is something important that in the end of the day, we are all just trying to access the, virtual machines. Yeah. So we have to just securely connect to virtual machines over the TLS connection. This connectivity can be established from the Azure portal or through the native client, to the private IP address of the virtual machine, so that they can actually just leverage that they are not going to have their virtual machines. They do not need a public IP address connections over the TCP port 443. For HTTPS, and then it can actually traverse most firewalls, and virtual machines are protected against port scanning, and then you're actually just using it as to constantly update and protect against zero-day exploits as well.
Let's
So
wrap up. We have another, very, of course, information full. We can cover this for hours. So I want to talk about the next session we will have for the
so
storage.
basically, again, like I mentioned, this is like, very open-ended, discussions. So right now, after the audience actually just goes through this, presentation, they are just going to see the zero trust, security, and then how they can actually just access Azure, and then how Microsoft makes sure that we're leveraging certain technologies in the best optimized way. Then we are just going to be looking at the storage accounts. So storage accounts is going to be the second phase of the zero trust security. And then we are going to be looking at the detection. Like, we're going to be looking at Azure Sentinel, for example, to make sure that Sentinel is
let's
actually...
key up our next episode. I think the storage encryption will be the next
storage
topic,
encryption is going to be next one. And then after that, we're going to be looking at the detection. And then we are just going to be speaking about like identity access management using Entra as well. And then overall, we will actually just like, get into the real cores of Azure zero trust security. But the note to the audience is that since this topic is very important and Microsoft has been spending over millions, like close to $1 billion, and sometimes we exceed, just to make sure that our customers' network are secure on Azure. So we are already protecting their resources by using certain technologies, but there's certain things customers need to do to protect their data, because data is their asset. They're responsible to protect the data. So we are given all the tools and technologies to make sure that their data is secure and protected at all times. So Linh, I would like to thank you for this awesome presentation. And then I look forward to speaking with you guys in the next chapters.
All right. Until the next time. Thank you, Evren.
Thank you so much. Thank you, guys. Bye-bye.